In this video we're looking at 2022 paper 1 question 6 and its differentiation. The first part of the question, we're told f of x equals 2x squared plus 4x, and we're asked to find the first derivative from first principles. Now obviously you should be able to look at the original question and you can tell the answer should be 4x plus 4, but make sure that you follow those steps that you've learned in class. You have to be very formulaic about it, and they're quite strict, so you have to make sure you follow each of these steps when you're asked to do it from first principles. In question 6 part B, we're told that the width of a rectangle is x centimeters squared. We're told that the length of the rectangle is always 4 times the width. So obviously that means the length is 4 times x. And remember, if we're dealing with a rectangle, the area of a rectangle is the length multiplied by the width. So if I multiply the length by the width, it's just x by 4x. That means the area of this rectangle is 4x squared. And the question is to find the rate of change of the area of the rectangle with respect to its width. In other words, find dA dx. dA because I'm getting the rate of change of the area. dx because it's the area with respect to the width. And I know the width is simply x centimeters. So that's probably the hardest part for students. You're being asked for the rate of change of area with respect to width. So that's dA dx. It's the rate at which the area changes relative to x, or relative to the width of this rectangle. Now, based on what I've done up here, I know that the area of the rectangle, I know that A is simply equal to 4x squared. So it's very simple to get dA dx. We just differentiate this. If you differentiate 4x squared, you're just going to get 8x. So if A is equal to 4x squared, then dA dx, the rate of change of area relative to x, is 8x. Well, we're trying to work this out at a specific, when the area has a specific value. We're told we want to find dA dx when the area is equal to 225 centimeters squared. So obviously I want to work out what is the corresponding x value when the area is 225. So that means I'm going to let the area, which is 4x squared, equal to 225. And then what we're going to do is we're going to divide both sides by x. We're going to divide both sides by 4. So x squared is equal to 225 divided by 4. In order to get x on its own, we would simply get the square root of both sides. So we get the square root of 225 divided by 4. And if you plug that into your calculator, x works out as 7.5 centimeters. In other words, when the area of this rectangle is 225 centimeters squared, the width of the rectangle is 7.5 centimeters. And I want to now sub that in. At this moment in time, the dx is 8x. Or in other words, the dx is 8 multiplied by 7.5. If we plug this into our calculator, 8 multiplied by 7.5, you get 60. So the rate of change of the area relative to x when the area is 225 centimeters squared is 60.
Now it's important that you don't forget to put in your units. So our answer is dA dx is equal to 60, but remember the x is measured in centimeters, and obviously the area will then be measured in centimeters squared. So the first unit, dA, is centimeters squared, and dx, the second unit, is centimeters. So the answer should be 60 centimeters squared per centimeter.
In the final part of question 6, we're given a curve of p of x, which is a cubic curve. We can clearly see that the minimum point is when x is 1, the maximum point is when x is 3. Now, one piece of information we're told is that the first derivative at 0 is equal to minus 3. We need to sketch the first derivative, in other words, the derivative of this. Remember that if you get the derivative of a cubic function, it's going to give you a quadratic function. In other words, if you have an x cubed and you differentiate it, you get an x squared. The first thing that you should notice here is that this is a cubic curve that starts as a U shape and then into an N shape. And we have learned that that means it's a minus x cubed. Maybe the first term is minus 2x cubed, or minus 3x cubed, or minus 4x cubed, but it's definitely a negative x cubed term that would give you this shape. If you differentiate a negative x cubed, like for example, if the first term was minus x cubed, its derivative is minus 3x squared. The point I'm trying to make is that if the cubic is a minus x cubed, when I differentiate it, I'm going to get a minus x squared. You should remember that a minus x squared is an n shape. So we need to sketch an n shape on our graph. Now, what I want you to think about here are the turning points. If I asked you to find the turning points, to find the minimum point and to find the maximum point of this cubic, well, what you would do is you'd get the first derivative and then you would factorize and solve the quadratic. In order to get a turning point, you differentiate and you get a quadratic, then you factorize and solve it. In other words, if I get my first derivative, which is a quadratic, the roots of that quadratic correspond to the minimum point and the maximum point. I can clearly see that the minimum point for this cubic is at 1, which means one of the roots of the quadratic would be 1. The other root of the quadratic would be 3. If I factorize and solve my quadratic, I would get 1 and I would get 3. They would be the roots of the quadratic, which correspond to the turning points of the cubic. So the question has told me that when x is 0, the first derivative is minus 3. So that's 1 point. And I know that the maximum minimum point corresponds to the roots of the quadratic. And another piece of information we're given is that the maximum value of p dash x is 1. So the maximum value is 1. And obviously if one of the roots is at 1 and one of the roots is at 3, then the maximum value is halfway between the two, it's here. So at the point where x is 2 and y is 1, that's the maximum value. One thing I would mention there, remember that it's a curve, so you cannot use your ruler. If it looks like you used a ruler to join your points up, then you'll be docked marks.
Okay, in part C of this question, we're given a function p of x. And p of x is clearly a cubic function. We can see the minimum point and we can see the maximum point. And we're given this function in the domain from 0 to 4. We're told that p dash of 0 is equal to minus 3, and we're asked to draw the graph of p dash x. In other words, we need to fill in as much information as we can about the derivative of this curve based on just looking at the curve. So here we're going to try and find five sets of coordinates, or 5 points that we can join up to draw the curve p dash x. First of all, you should recognize that if the original function, if p of x is a cubic function with 2 turning points, then the derivative will be a quadratic function with 1 turning point. So we're just trying to draw a quadratic function here. Another thing I'd like you to cop is that if you have a cubic function that goes down first and get the minimum point and then you get the maximum point, that's a minus x cubed. And if you differentiate a minus x cubed, you get a minus x squared. So you should recognize that we're expecting the derivative to be a minus x squared, or in other words, an n-shaped curve. That's what we're going to end up with here. So let's just start trying to fill in and get a few coordinates. We're actually given one of our points here. We're told that if I sub in 0, I get minus 3. In other words, one of the points on this curve is the point 0, minus 3. When x is 0, the y value is minus 3. Now we should focus on the turning points of p of x. Think back to how we identify turning points. In order to identify the turning point of a function, we get the first derivative and let it equal to 0. Because at a turning point, the first derivative is equal to 0. One of my turning points is when x is 1. And if I'm trying to draw the derivative of that, well, I know that at the turning point, the first derivative is equal to 0. So I know that the point 1, 0 must be on the derivative. The other thing we can look at is the maximum point. The maximum point is clearly at the point 3 in the original function. And I know that at the maximum point, the first derivative is equal to 0. So if there's a maximum point at 3, that means in the first derivative, when x is 3, the y value is 0. Or in other words, the first derivative is equal to 0. Now we're also told that the maximum value of this derivative is 1. And if you should recognize that the maximum value has to be halfway between when x equals 1 and x equals 3. If I know that it crosses the x-axis at 1 and it crosses the x-axis at 3, then it has to have its maximum value halfway between those two turning points. Halfway between 1 and 3 is 2. And the question said that the maximum value of this derivative is 1. So that tells me that the point 2, 1 has to be the maximum value of this quadratic. And the last point we need to find is to the right of 3. I can see that to the left of x equals 1, I go over 1 and down 3. So obviously it's going to be the same thing over here. I'm going to go over 1 and down 3. So I can tell that the fifth point on this curve is the point 4 minus 3. So my 5 sets of coordinates, well, the first one we identified here was 0, minus 3. Then we identified the 2 points where it crosses the x-axis. One of the points here, I could mark that in, I'll put it in here as 1, 0. This point where it crosses the x-axis is 3, 0. We've identified that the maximum point is the point 2, 1. And we've identified that the point furthest to the right is the point 4, minus 3. So that's our 5 points, and then we just have to join them up. And remember, it's a curve, it's an x squared, so if it looks like you used your ruler, then you'll be docked marks. You cannot use a ruler because none of this curve is straight. It has to look like you just did it freehand. So if you found those 5 coordinates, that'll give you the marks for part C here.